This video is going to fill out the bottom flap of section number 6 in your Unit 11 Quadratic Relations flipbook. Bottom flap of section number 6. The essential question is, how do I find the focus and directrix of a vertex form quadratic equation? So, if you remember in the previous video, we were given the focus and directrix, and from that information we had to find the equation. In this case, we are given the equation and we're having to find the focus and directrix. So let's take a look at our equation. This is in vertex form, and we already know a few things, class. We know this is the value of h, this is the value of k, and this is the value of a. So let's write that information down and see how we use that to find the focus and directrix. So our vertex is going to be at h comma k, and looking at our equation, we have an h value of 1 and a k value of -3. Remember, you flip the sign of h and you keep the sign of k. I'm going to just label these here. Actually, that's good enough. I think we're good. So we've already found our vertex. Hey, let's graph it right now. 1 comma -3. So right here, I'm just going to put a V there to represent the vertex. All right. Next step is we know the value of A. We're going to have to find the focus and directrix, and to get those two things, we're going to have to find the value of P. So from our quadratic equation, we know that A is equal to -1/4. Well, our P value is found with the equation 1/4, oops, let's write that a little clearer, 1/4A. Now this is interesting. Look back at our previous work. We found that if we knew what P, the value of P was, then A was equal to 1/4P. What's kind of cool is, if you know what A is and you want to find the value of P, it's the same fraction. You just substitute the other letter. So P is equal to 1/4A. Well, we've got 1/4 times -1/4. And if you multiply 4 times -1/4 in your calculator, you will get -1. These are actually reciprocals. They're actually opposite reciprocals. So we're going to end up with -1. So this is going to be 1/-1, and we can just simplify that as, if you do 1 divided by -1, you're just going to get -1. So our P value is -1. Let's circle the vertex too, so we know that's important information. So our P value is -1. Remember what the P value is, class. The P value is the measure from the vertex to the focus. A positive number means you go up from the vertex. A negative number means you go down. If you look over here, we go down from the vertex. So if our P value is -1, we're going to actually go down from our vertex. And it's 1 unit. So we're going to go down 1 unit. And that is going to be our focus. So let's put over here, let's put a little note here. This is going to go, we're going to go down. So there is our focus. And let's put a little note here to remind us of this. So the focus is 1 unit below the vertex. So if that P value was +2, we would count 2 units up from the vertex. If the P value was -4, we would count down 4 units from the vertex. So now we've got our Focus. We've covered the focus. We've found and labeled the vertex. Now we have to find the directrix. Now what we've noticed in an activity that we've previously done, the directrix is going to be on the other side of the vertex. It's opposite from the focus, and it's exactly the same number of units away as the focus. So if our p-value is -1, that's how we got the focus, we're going to go +1 to get our directrix. And I'll go ahead and draw our directrix right here. Oops, let's make that a much neater straight line. So this must be our directrix. And I'm just going to label that as D. That's good enough. Our directrix is D. Okay, so we have labeled our, let's make a note here, directrix. This will be good for you guys to be able to reference. Directrix must be 1 unit above. So whatever direction we go to get the focus, we go the opposite direction to get the directrix, above the vertex. Now we've got everything labeled. Let's see what our question says again. Label the vertex, we got it. The focus, we got it. The directrix, we got it. Oh, we got to label the axis of symmetry. Well, the axis of symmetry goes directly through the vertex. Let's pick a different color here, and let's label the axis of symmetry. It's going to go straight through the vertex, and of course in this case straight through the focus. And we'll label that as axis of symmetry. Alright, before we do anything else, class, it doesn't ask us to do this, but let's graph this parabola. Remember our shortcut to graphing. If we know where the focus is, and we know that the p-value is equal to 1, then we know we're going to get 2 points on the parabola that are 2 times p away from the focus. So if the p-value is 1, we're going to go 1, 2 to the left of the focus, and 1, 2 to the right of the focus. Excuse me. And now we're going to go ahead and sketch our parabola. Let's pick light blue. So here is our parabola. There's our one side, and there's our other side. So these 2 points that are 2 times p to the left and right of the focus, they help us determine about how wide our parabola is. Not a perfect parabola, but it's better than just guessing at what the width is. And up here, class, I didn't specify this for you, but I have talked about it in class, that in this case I just estimated the width of the parabola. Now you're seeing that we can actually get a pretty good idea what the width is, because we know that the distance between the focus and the points to the left and the right of the focus that are on the parabola are 2 times p. So in this case 2 times 1, so 2 units away. Let's write our final information over here on the left side, then we'll continue with the other graph. Okay, so our vertex was at 1, -3. Our focus was at 1, -4. Our directrix was on the line y equals -2, and our axis of symmetry, that's a vertical line, that is where x equals 1. There's our information for that problem. Alright, let's take a look at the next one. Only got about 6 minutes to go, so I gotta hustle. Finding the depth of a parabola, so make sure you have that title, Finding the depth of a parabola. The cross-section of a television antenna is a parabola. For the dish below, the receiver is located at the focus 4 feet above the vertex. You can see right here, if we want to pick this as our vertex right there, we can see that the focus is right here. I'm going to label that F, and I'm going to label this V. Find an equation for the cross-section of the dish. Basically, they want to know what's the equation of this shape, this parabolic curve here that makes up the satellite or the antenna. Assume the vertex is at the origin 0, 0. If the dish is 8 feet wide, how deep is it? Alright, let's go through this. First thing we're going to do is we're going to verify that this is our vertex. It says the vertex is going to be at 0, 0. So I'll put vertex at 0, 0. We also know our focus is going to be at 0, 4, because you can see our focus is 4 feet, 0, 4. Our focus is 4 feet above the vertex. Alright? So now we got to figure out how to find the equation for this. Well, I can tell you, we know what the p-value is already. The p-value is the measure from the vertex to the focus, which in this case is 4 units. We go up 4 units. So p is equal to 4. Alright? And also what we want to do is want to figure out something about this parabola. We know that the ends of the parabola are out here somewhere. We just don't know where they are exactly. But let's plot the two ends of our dish, and we'll go ahead and sketch this. So let's sketch this parabola out. There we go. I'll do my best to sketch what that parabola looks like. Now we do know something about these points, class. If the parabolic dish, or the antenna, is 8 feet wide, that means that the x value of this point right here is at 4. And the x value of this point right here is at -4, because we go 4 feet this way and we go 4 feet this way. So we know something about those 2 points. In fact, I can label this one right now. I know the x value is 4. What I don't know is the y value, and that's what we're going to have to find out. So let's get some detailed information down here right below this parabola. Follow with me. Okay, we know that our p value is equal to 4 minus 0, which is equal to 4. We just subtracted the location of the focus from the vertex. Okay. The vertex we know is at 0, 0. So h equals 0 and k equals 0. So we know, oops, that's k equals what? K equals 0. So we know h and k. Let's find out what our a value is. If we know what p is, we can find a. A is equal to 1 over 4p, which is equal to 1 over 4 times 4, which is equal to 1/16. And this makes sense. It's positive. Okay, I'm going to put it's positive because we know this parabola faces up. So we've got our a value. Let's go ahead and write our equation now. So our equation is y equals 1/16 times x minus 0 squared plus 0. Okay, well, that means we can write our equation as y equals 1/16. We don't have to write the zeros anymore. Times x squared. We could get rid of the 0 here and get rid of the 0 here. Here's our equation for this parabola. So we have solved the first problem. What is our equation? The next question, if the dish is 8 feet wide, how deep is it? They want to know how far is this distance from the end point to the top. So this is how deep it is. How deep is it? Alright, all we got to do, class, is substitute this point into our parabola equation and solve for x. So let's go ahead and do that. Sorry, solve for y, because we know what x is. So let's substitute that in. We're going to say y is equal to 1/16 times, we know this point, x value is 4. It's going to be 4 squared. That means y is equal to 1/16 times 16. Well, that works out pretty nice. That means y is equal to 1. So y is equal to 1 foot. So this distance right here, the depth, I'm going to go ahead and write it here, is actually equal to 1 foot. And there is our answer to how deep it is. So hopefully you followed this. Listen to it again if you need to make sure you understand the step to solve this.